we are going to be discussing the domain and range of functions. A quick little refresher here on our different notations. You are probably most familiar with inequality notation, possibly interval notation. Using an inequality to describe intervals is very common. If we do not include an endpoint, we just do a less than or a greater than sign. If we are including the endpoint, we do this closed dot in the picture, and it's a less than or equal to or greater than or equal to. So you see the difference. There's a line underneath the second one, but not the first one. Same thing down here. I am including 5 in my interval. I am not including 10. So this is all of the numbers, including 5, going up, up, up until just before 10. So 9.9999999 is included, but 10 is not. So H would be the numbers greater than or equal to 5 and less than 10. Right now here, we have none of the we do not have 5, but we have all the numbers right up to 5. So 5.0000001 and all the way up to 10, 9.99999, those are all included, but it's just two less than signs because that is all we are working with, is the numbers in between. Now, if we have something that's going on, it's all of the ones less than 10. So this goes way past 5, all the way to infinity. That's going to be a less than sign as well. Now you'll notice I've been skipping over the interval notation for a moment. You'll notice when we would use just a regular sign, a regular less than sign, and no bar underneath it, we use parentheses at the end of our interval notation. And over here, we use a bracket if we want to say that it is equal to 10, that it includes 10 in the interval. All right. If we are talking about infinity, we never include infinity. Infinity is some idea that we cannot actually reach, so we do not include it in our interval notation. Here, for example, we are including 10, but going off to positive infinity. So we have h is greater than or equal to 10. So we have a bracket by 10, and we have a parentheses around infinity. When it's all real numbers, we do negative infinity to infinity. If you are interested in set builder notation, you are welcome to go over this. This is h such that, that's what that line means, such that, and then basically you copy the inequality notation. All right, set builder notation is important later, but you are not required to learn it right now. All right, let's look at an example. So we are asked to describe the interval as an inequality. Oh, this is not supposed to be here. And in interval notation. All right, so describing it as an inequality, well, let's look at what we have. We have two different areas right here. We have 1 to 3, and it does include those endpoints. So 1 to 3, including the endpoints as an inequality, let's say this is x right here. That means my x is always greater than or equal to 1 because of the closed dot, and it is less than or equal to 3. It sits in between those two. In interval notation, these would be closed brackets because they are closed dots and we are equal to them. So 1 to 3. All right. Now this one over here, we have an open circle, and then the arrow continues on off to infinity. So that tells us that x is going to be greater than 5 and not equal to it. All right. So you could write this the other direction, x is greater than 5. They will both work, okay? But x is greater than 5, not equal to it. So in interval notation, we would not include the 5. So we would have a parentheses, comma, infinity. And infinity is not included either, so we have parentheses there as well. All right, let's do example 2. So in example 2, it asks us to describe the domain and the range. So domain and range of the function, f of x as an inequality, and in interval notation. So domain is our x values, range is our y values. So the domain, let's look at this. As I move along this graph, my x values are these right here, which x values are inputs, proper inputs to this function. And as we can see, all of the ones displayed, what's displayed on the graph is from here to here, correct? And I may be tempted to say that it's negative 3.5 to 5, but that is incorrect because this graph continues on this direction and continues on this direction forever in both directions. So that means that my domain will be all real numbers negative infinity to infinity. Now, my range is discussing the y's. This is a little bit more tricky from this graph because we may be tempted to say that y stops right here at 2. Now, from the way the graph is being read, though, this graph continues on up there and continues down here, and it does not tell us it does not stop. So, because of that, we're going to be seeing our range as also all real numbers from negative infinity to infinity. All right. Okay. Example 3, describe the domain and range of the function g of x as an inequality and in interval notation. So same thing here. Domain is x, range is y. All right. So our domain of the function is all the x values that might be included here. Okay. So all of these x values, let's look at this. Does my function continue on to the left forever? Yes. Does it continue on to the right forever? It does. These arrows indicate that it keeps going. So I have all real numbers or negative infinity to infinity. Okay. Now, if this, for example, had turned and gone like that instead, that would mean that I would be from, well, that goes into our y's. Let's go to that in a second. So let's ignore that change I made for a moment. All right, so range. Currently, this function continues up forever and continues down forever. So our range is all real numbers. And it's from negative infinity to infinity. Those are the two ways of writing it. Now, as I was stating before, if this were to turn around and go up, now the lowest it goes is to here. So that's probably about negative 1/3, right? So with this edit, we now have a range that goes from negative 1/3, and we'll say it includes it, up to infinity, and we don't need to include that there. We could write less than infinity, or we can just leave it right there, that y is always greater than or equal to negative 1/3. The other way to write this would be negative 1/3, if we're including it with a bracket, negative 1/3 to infinity. All right. So that's the difference that this little change makes if our function were to turn, right? The lowest we would go would be right here. All right. Example 4, describe the domain and range of the function h of x as an inequality and in interval notation. So we'll use the same colors here. So domain is x, range is y. All right, so our domain, our x values, it's not very often that we see domains that don't stretch on forever. You'll start to see them more later, but you'll see we keep going off to the left and we keep going off to the right. This function continues off in both directions. So our domain is all real numbers. It's our shorter way in interval notation, and negative infinity to infinity is, that is interval notation. This would be my inequality notation because I don't have an inequality in this case. My range. The lowest I go on my function is right here at negative 3. I don't ever go lower than negative 3. So this means that y is always greater than or equal to negative 3. Okay? I could write this as y is greater than or equal to negative 3 as well. They both work. Then this is inequality notation. Interval notation is that my function goes from negative 3, we're including negative 3, so I need the bracket, negative 3 up to infinity.